Several potential causes could explain why circuit breakers fail even when the connected appliances are not in use. Firstly, consider an arc fault. An arc fault can occur when there is a loose connection or insulation breakdown within the breaker. The arc can generate heat and damage the breaker, potentially causing it to fail and open the circuit. This can happen even if the appliance it is powering is not in use. Secondly, overheating could be the issue. Circuit breakers are designed to trip when they carry too much current for a sustained period. However, in rare cases, the breaker itself can overheat due to a high resistance connection or loose terminal. This can damage the breaker and lead to failure. Thirdly, it could be a surge protection failure. Some circuit breakers have surge protection built in. If the surge protection component fails, it can allow a surge of electricity to reach the circuit, damaging the breaker. Fourthly, manufacturing defects can occur. It is possible that the breakers were defective from the factory, making them susceptible to failure under normal operating conditions. The fact that the basement lights and air conditioner were not running at the time of the incident suggests that the failure was not caused by excessive current draw. Instead, it is likely that one of the above-mentioned causes triggered the breaker failure, and the loss of power to the lights and air conditioner was a consequence. When dealing with electrical issues, safety is paramount. It is advisable for an electrician to inspect the panel board to assess the extent of the damage and identify the root cause of the breaker failure. They can also check for any other potential electrical hazards to ensure the safety of the home. A thorough inspection of the panel board is necessary to determine the underlying issue. The electrician will likely examine the bus bars for any signs of corrosion, overheating, or physical damage. The connections of the breakers to the bus bars will also be checked to ensure they are tight and making good contact. A loose connection can create resistance, leading to heat buildup and potential breaker failure. The electrician may use thermal imaging to identify hotspots within the panel. This technology can detect areas of excessive heat that are not visible to the naked eye. Hotspots can indicate loose connections, overloaded circuits, or failing components. The electrician will verify that the installed breakers are the correct type and size for the circuits they protect. Using the wrong type of breaker or a breaker with an incorrect amperage rating can create a dangerous situation. The electrician will also test the voltage and current on the affected circuits to ensure they are within acceptable limits. Abnormal voltage or current readings can indicate a problem with the wiring or connected appliances. The electrician should also investigate the possibility of a surge event that may have damaged the breakers. Surges can come from various sources, including lightning strikes, utility switching, and internal appliance malfunctions. Installing a surge protector at the main panel can help protect the electrical system from future surge events. If the electrician finds evidence of an arc fault, they will need to trace the circuit to locate the source of the arc. Arc faults can be caused by damaged wiring, loose connections, or faulty devices. Once the source of the arc is found, it must be repaired or replaced to prevent future problems. Over time, circuit breakers can degrade due to age, heat, and repeated tripping. If the breakers are old or show signs of wear, the electrician may recommend replacing them. Replacing all the breakers in the panel can be a proactive way to improve the reliability and safety of the electrical system. The National Electrical Code, or NEC, provides guidelines for electrical installations and safety. The electrician will ensure that the electrical system is in compliance with the NEC. This includes proper wiring methods, grounding, and overcurrent protection. The electrician will provide a detailed report of their findings and recommendations. The report should include a description of the problem, the cause of the problem, and the steps taken to correct the problem. It should also include any recommendations for future maintenance or upgrades. Regular electrical inspections can help prevent problems before they occur. An electrician can inspect the electrical system on a regular basis to identify potential hazards and ensure that it is operating safely. A whole house surge protector can protect the electrical system from voltage spikes. Surge protectors should be installed at the main panel and at individual outlets to provide comprehensive protection. Ground fault circuit interrupters, or GFCIs, protect against electrical shock. GFCI should be installed in wet locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or SIs, protect against arc faults. SIs should be installed in bedrooms, living rooms, and other areas where arc faults are more likely to occur. Smoke detectors provide early warning of a fire. Smoke detectors should be installed on every level of the home and in every bedroom. Carbon monoxide detectors protect against carbon monoxide poisoning. Carbon monoxide detectors should be installed on every level of the home and near sleeping areas. Extension cords should be used only temporarily. They should not be used as a substitute for permanent wiring. Extension cords should be properly sized for the appliances they are powering. Overloaded extension cords can overheat and cause a fire. Electrical outlets should not be overloaded. Overloaded outlets can overheat and cause a fire. Appliances should be unplugged when they are not in use. This can save energy and reduce the risk of electrical shock. Electrical cords should be inspected regularly for damage. Damaged cords should be replaced immediately. Water and electricity do not mix. Never use electrical appliances near water. If you have any questions about electrical safety, consult with a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips, you can help protect yourself and your family from electrical hazards. Breakers are critical safety devices in any electrical system. They are designed to protect circuits from overloads and short circuits. When a breaker trips, it interrupts the flow of electricity, preventing damage to wiring and appliances. There are several types of breakers available, each designed for specific applications. Single-pole breakers are typically used for 120-volt circuits. Double-pole breakers are used for 240-volt circuits. Ground fault circuit interrupter, or GFCI, breakers are used to protect circuits in wet locations. Arc fault circuit interrupter, or RFSI, breakers are used to protect against arc faults. Breakers are rated in amps, which indicates the amount of current they can safely carry. It is important to use the correct size breaker for the circuit it is protecting. Using a breaker that is too small can cause it to trip frequently. Using a breaker that is too large can allow the circuit to become overloaded, which can lead to a fire. Breakers should be tested periodically to ensure they are working properly. This can be done using a breaker tester. If a breaker fails to trip when it is supposed to, it should be replaced immediately. Replacing a breaker is a relatively simple task that can be done by a qualified electrician. However, it is important to follow safety precautions when working with electricity. Before replacing a breaker, turn off the power to the circuit at the main panel. Wear rubber gloves and eye protection. Use insulated tools. If you are not comfortable working with electricity, hire a qualified electrician to replace the breaker. The electrical panels are the heart of any electrical system. They distribute power to all the circuits in the building. Electrical panels should be inspected regularly to ensure they are in good condition. Look for signs of corrosion, overheating, or damage. Make sure all the breakers are properly labeled. This will make it easier to identify and troubleshoot circuits in the future. Keep the panel clean and free of debris. Dust and dirt can accumulate and cause the panel to overheat. If you notice any problems with your electrical panel, contact a qualified electrician immediately. Do not attempt to repair the panel yourself. Working on an electrical panel can be dangerous. Only qualified electricians should work on electrical panels. Electrical wiring is the lifeline of any electrical system. It carries power from the electrical panel to all the outlets, switches, and appliances in the building. Electrical wiring should be installed properly and maintained in good condition. Use the correct type and size of wire for the circuit it is serving. Make sure all connections are tight and secure. Protect wiring from damage. Do not run wiring through walls or ceilings without proper protection. If you notice any problems with your electrical wiring, contact a qualified electrician immediately. Do not attempt to repair the wiring yourself. Working on electrical wiring can be dangerous. Only qualified electricians should work on electrical wiring. Electrical safety is everyone's responsibility. By following these safety tips, you can help protect yourself and your family from electrical hazards. Always turn off the power before working on any electrical equipment. Never touch electrical wires with wet hands. Never use electrical appliances near water. Keep electrical cords away from heat and sharp objects. Do not overload electrical outlets. Use extension cords only temporarily. Have your electrical system inspected regularly by a qualified electrician. If you have any questions about electrical safety, contact a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips, you can help protect yourself and your family from electrical hazards. It is important to understand the basics of electrical circuits. An electrical circuit is a path through which electricity flows. A simple circuit consists of a power source, a conductor, and a load. The power source provides the electrical energy. The conductor carries the electricity to the load. The load uses the electricity to perform work. There are two types of electrical circuits: series circuits and parallel circuits. In a series circuit, the electricity flows through all the components in the circuit in a single path. If one component in the circuit fails, the entire circuit will stop working. In a parallel circuit, the electricity flows through multiple paths. If one component in the circuit fails, the other components will continue to work. It is also important to understand the difference between voltage, current, and resistance. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the rate of flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical current. It is measured in ohms. Ohm's law states that the voltage in a circuit is equal to the current multiplied by the resistance. Understanding these basic concepts is essential for working with electricity safely. Always consult with a qualified electrician if you have any questions about electrical circuits or electrical safety. Remember to always prioritize safety when working with electricity. Double-check your work and test your circuits. Be aware of your surroundings and potential hazards. If you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous if not done properly. It is always better to be safe than sorry.